Hi there, this video is a follow-on from dismantling a domestic microwave oven. So what we've got here is three capacitors. The one on the right hand side was a faulty capacitor taken out. It was faulty because the dielectric has failed. There's a short circuit on it. It blew the high voltage fuse, so the magnetron wasn't getting any power and the food was not being heated. So what we expect to see on capacitors that work, these are other two capacitors taken out of a microwave oven. We want to measure their capacitance on a meter to see if they're working and fit for purpose so that we can use them for other projects, or we can see if there's any resale value on eBay or other platforms. So you can buy these brand new on Amazon and eBay for £6, £7, £8. There may not be substantial amount of money to be made by selling second hand. However, there is parts that we can dismantle. So what we're going to do is, just to make sure, before we measure capacitance, we want to make sure that these capacitors are discharged. They do have an internal bleed resistor, but you should not rely on that. Typically they are 10 megohms. However, they can fail as well. So what you want to make sure, 100 ohm resistor, we want to discharge the capacitor and make sure it's fully discharged. So we'll do the same with the other one, because we're going to measure capacitance on here. 100 ohm resistor. So if there's any charge in there, it will dissipate through the 100 ohms. And we'll do exactly the same on this one as well. We will discharge it through there. So what we want to do is to measure the capacitance of this one here. It says it is 1.07 microfarads. Let's see what we're measuring out of here. We've got 0.96, so that will appear to be fit for purpose. Let's measure the other one, and let's see. It measures 0.96 as well, 95. So they appear to be working. What about this capacitor here that is the faulty one? If you measure capacitance on it, the steel clips there, so we simply do not get a reading. Yeah, we don't get a reading there. Yeah. So it's saying 0. So what, just to double check, if we put the meter to the ohmic setting, let's put it on the highest, put it on 20 megs. There are internal 10 meg resistors in these capacitors. Let's see if we measure the resistance of it. To put the leads together, measure 0. If we put the leads on this faulty one, it's measuring 0 on that one. On capacitors that we've already checked the capacitance is good, what would be the ohmic reading that we typically get? It's charging up there because there's a voltage coming out here, a very small voltage of a few volts, so it is charging up the capacitor here, but it will stabilize itself up above 10, 11 megs. It's charging up, which you would expect because there is a voltage coming out of the meter. Okay, so it's charging up 10 megs. That would be typically what we expect to see. If we do it on the other good capacitor, just double check, we get 0. It's been previously discharged. Again, what it's doing is it's charging up there because there's a voltage out of the multimeter. It should charge up to approximately 10 meg ohms, because that's the value of the bleed resistor if there's no short circuits on the capacitor, and we can see it's doing that there. So this capacitor here is lost its properties. It's got dielectric breakdown, it's effectively got a short circuit. Dielectric strength can be dependent on temperatures. The temperature goes up, the dielectric strength, kilovolts per millimeter, can go down. As the temperature goes up, the surface life also goes down. Oil is used as an insulator. So this oil was taken out of this capacitor. These capacitors have got rolled seam technology similar to canning of food. This one's This one here is already been partially dismantled, and what we want to do now is dismantle it and see what type of dielectric. So this is faulty. It's got dielectric breakdown, it's got a short circuit. So what we want to do, let's take that off there, we'll switch this off. These are the good capacitors. What we want to do now, switch that off. It has been cut open, so again just be careful. There is oil in here that's been taken out. It's not really under pressure as such, but you should wear safety glasses. We can see here the bleed resistor here, so that appears to have been, it's connected in parallel with the capacitor, so because it's got a short circuit through the dielectric, this is effectively taken out of the circuit. So there are materials that we can recycle in here. Aluminium can, so we can recycle the aluminium. The steel, the connectors are steel, so we've got a magnet there, so they are steel. And what we want, and the bleed resistor, we could take that out and measure its value there. So as we can see on the charts here, we've worked out the bleed resistor isn't particularly large physically, it has to dissipate heat. Why is it not particularly large? Well, it's 10 megohms. If we work out the current, it's quite a tiny current, 2.1 times 10 to the minus 4, so that's 0.21 milliamps. If you do the power rating I squared R, it comes out to be 0.44 watts. So this resistor isn't particularly big physically to dissipate any heat. So we will recycle this resistor as well. We can always use it on other projects. So what we want to do now is we've taken that off. We've got the resistor on there, we'll take that off later. What we want to be able to see, you can see the rolled film here. There will be aluminium foil with probably paper or polypropylene dielectric insulation material between it, which is what has failed. So let's see if we can get these connectors out. These are these are aluminium there, and pull these out as well. And the tags out, they'll be aluminium. So we've still got a little bit of oil in here. So this is an aluminium can. We can recycle the aluminium. We will get the oil out of here later. We can see the rolled film here. We can take that out, and we can see that it's oil impregnated in here. So it may actually be paper. It's actually quite difficult to tell, but it's actually rolled film technology. So it's round in a film. There's two foils, the actual plates, and then there's dielectric material between it, which is probably paper that's been immersed in oil. So the oil helps with heat dissipation. So what we're going to do is, this will effectively be binned. It's obviously failed anyway, the dielectric. And what we'll do is we'll clean this out. The capacitor, we can recycle the aluminium parts here, and we can recycle if we can get them off, we'll recycle those steel tags, and we'll use the bleed resistor, the 10 megohm, on other projects. So that completes what's inside a high voltage microwave oven capacitor that has to be able to handle typically 2000 volts for the magnetron. Thank you for watching.